Unit 3, Learning Target 4C, I can perform function composition. So before we get into this, let's just do a real quick review off to the side right here. If I said f of 3, you would take 3 and you would substitute it in for the x value in the f function. So you would say 3, and then instead of putting x right here, you're going to put 3 plus 2. 3 plus 3 is 9, plus 2 is 11. So just a reminder, whatever's right here in parentheses, that's what you're going to substitute into the function. So let's look at example 1. There are two different ways that this is written. It can be written one of two ways, and they mean the exact same thing. So let's look at the second option first. Do you agree that g of x is written on the inside of the parentheses just like 3 was written on the inside of the parentheses for the review? Hopefully you see, yeah, that it's just written on the inside of the parentheses just like the 3. So what you should think then, if we took 3 and substituted in for x, you should think, okay, well, we're going to take g of x and sub in for x. So let's see what that would look like. If we took this and we filled it in right there for x, we would have 3 g of x plus 2. But we know that g of x is x squared minus 2x. Well, from there we can distribute our 3 and get 3x squared minus 6x and bring down our plus 2. We have just performed function composition, and it's no different from what we've done before. So let's talk back about the first way that this was written. This open circle, it's not a dot. The dot means multiply. This is an open circle. That open circle means of. So you would say this f of g of x. Just like over here, you would say f of g of x. So they're written two different ways. It means the exact same thing. All you're doing is you're taking whatever the second thing is and you're filling it in for the first thing. So we took g and we filled it in for f. So let's look at example 2. This one says take whatever f is and we're going to fill it in for g. Written the other way, it still says take whatever f is and fill it in for g. So we're going to take this function, f, and we're going to fill it in for the x values in g. So we would say f of x squared minus 2 f of x. We take whatever f is and we fill it in for g. So f is 3x plus 2 squared minus 2 and 3x plus 2 again. We took this function and we filled it in for g. So we've got 3x plus 2 squared. Don't forget, something squared means multiply it by itself. We can go ahead and distribute that negative 2 if we'd like to get negative 6x minus 4. We know these parentheses next to each other means to distribute. So the first two would give us 9x squared. 3x and 2 give us 6x. 2 and 3x give us 6x. 2 and 2 give us 4. Then we just bring down our 6x minus 4. Combine our like terms. So we've got 9x squared, and that's the only thing that's squared. We've got a 6x plus 6x, so that's 12x, and minus a 6x. So that's just going to be 6x. We've got a positive 4 and a minus 4. Well, those are going to cancel each other. So there's our final answer. Alright, one more example. F of x. So both of these say the same thing, then for the first thing. Take whatever the second thing is, and you fill it in for the first thing. So this one looks a little bit weird because it says take f and put it back in for f. That's exactly what you're going to do. So let's write down f is 3x plus 2, but instead of x, we're going to fill in f of x. And then we know that f of x is 3x plus 2, because that's what it says up top. So distribute our 3's, and we're going to get 9x plus 6 plus 2. Combine like terms and get 9x plus 8. Okay, so don't forget the difference between f of g versus of x versus f times g of x. This means multiply. This means take the second one and fill it in for the first one. That's how you do function composition. Have a wonderful day.